We're going to do figure P6-7 as a multi-body, sometimes called master model part, and then extract that information into individual pieces and an assembly. The other method that we'll do in the second video for this figure will be a top-down assembly. So it just gives you a comparison of how to manage, or if you encounter these parts, what the logic behind it is. So this piece has three. We have the chamber, the base chamber, the gasket, and where did it go? The cover plate. All right, so those three pieces we could pretty much create in just one sketch, create all three bodies, name those bodies, and then extract the information. So the advantages of multi-body and top-down is that there are single points of failure. That means if there's a problem, we're going to go back to maybe one or two original sketches, or in some cases a single 3D sketch, and we'll be able to diagnose maybe 70–80% of the problems from that one sketch. All right, we'll go through in the toolbox and we'll add the fasteners. This will also be our introduction to toolbox for the assembly. All right, so one of the things I noticed in the last video is that my SolidWorks and this screen, let me pause for a second, and I just wanted to check that I'm at screen resolution of the 1920 by 1080. So let's go ahead and start with a part, and this is in metric, so let's just go to our standard part still, and we'll go through the entire sequence of creating our templates again. Alright, so one of the things I noticed is that my icons were a little bit small, so use large buttons with text is handy, but if I customize, we can come over to the icon size, and it's going to warn me that it might not resize until next time I start. The last video also had the little tooltips showing up with pictures, which could be handy, but it was also kind of annoying. And then if we go to the really big, that might work better for our videos. So I lose a little bit of the work area, but for the most part, that should be a little bit more visible. Doesn't look like the tabs jumped up a whole lot, but kind of manage your work area in the icons. Doesn't look like the text got a little bit, so maybe that's the one when I restart SolidWorks it'll come back. So let me pause again. Alright, so I shut down my SolidWorks and restarted it, and kind of disappointed that the text size, so that must be related to Windows and the Windows text size. So rather than playing with that during a video, I'll look at that offline and see if I can come up with another option. Okay, so looking back at our part, I'm looking at these as three revolves. So the top one, we can just do the rectangle. The second one will do the rectangle, and the third one will do this L shape. Now, if I manage this right, I can generate all of this out of one sketch and reproduce and have those geometries available to all of the parts. Right, so I'm going to go into the front plane. Anytime that I'm doing a revolve, I'm going to go to the center line, and we'll go vertical, infinite length, attach it to the origin, and then I'll just escape out. L on the keyboard is my quick shortcut. Also looks like, oh, maybe that was me pressing on my volume. There we go. And I'm going to see if we're in inches. So let me take care of that first. So as soon as you realize you're in inches and you want to be in millimeters, or realize you're in millimeters and want to be inches, that's the time to change it. So if I go over to millimeters, grams, and seconds, it's going to kick me out of the sketch. I kind of expect that. Does it every time. I'm going to go back over to the sketch one, right click and edit sketch. That puts me back into the view, and it even zooms up for me. We go with the L on the keyboard. I'll just pick the from the command. Alright, so there is my first part. And if I do this as contours and regions, I am going to want to close this off. I'm not sure if the whole wizard has that M24x3 thread. So I'm going to plan for the eventuality that it does not by putting in a kind of a placeholder for the hole. The gasket then, and keep in mind that their drawing was in an exploded state. These are for our assembly meant to be in contact with each other. Alright, and so since I'm just tying those regions together, this is also an M24, so I'll highlight it together. Alright, so this looks a little strange. It is a slightly different logic, and we're ready to start putting our dimensions in. So let's take a quick look. The diameter of 100 is all 3 parts. And then we have, oh, that one has the hole in it, so I'm going to need that, or is it the same size? Diameter of 60, don't see that one. Yep, also a diameter of 60, so that should be okay. Alright, so the advantage of the center line again is that I can go between the object and the center line and get its radius, and go to the other side, and we'll get a diametral dimension. So there's the 100, and then I have the part on the other screen, so I'll refer you back to it as you need. So 65 millimeters. Since it's still in diametral, I'm going to hit escape, and that is pretty close. The gasket is 3 millimeters thick, and the cap is 13 millimeter thick. And then our interior was 60 millimeters. Alright, so everything's starting to become defined. The way that we manage the metric, and we can go back and look at the thread callout, is that M24x3 with metric, we take the first number is the major diameter, the second number is pitch. The first number subtract the second number will give you the minor diameter. Alright, so just in case I need to approach this some other way, we'll place this and give it 21, and OK. And then the last thickness on the base was 20. Alright, so there's our shape. Alright, so what makes this a master model or a multi-body part is that when I go into the features, I'm going to reuse this sketch to make all 3 pieces. Alright, so there is one center line. I'm going to try and keep it that way. And for the contours, if I go to that route, it kind of stops, doesn't go all the way around, but if I pick regions, I can get that entire geometry. Choice I have to make here is, do I want to build out each of the bodies and then go through the process of adding the whole features, not any other geometry that we're looking for, quick glance. So the 8 holes and the clearance holes. So we'll go through and build out as much of the geometry in one part and then go to the next. All right, so I can reuse some of these sketches, and we'll go through the process. So I'm going to pick the bottom of the part. My S key takes me to where I can select for the hole wizard, and this is going to be a threaded hole. We'll reset. I'm not sure what I did last time, but we'll go to Ansi Metric. This is just going to be a tapped hole, and we go down a little ways, and there is an M24x2 and M24x3. Okay, so on this one we'll utilize the our hole wizard item. We have the up to next with a thread callout, and I'm not too worried about tolerance and precision at this point. Because I pre-selected the face, I'm automatically going to be asked where to position. Position is at the origin, and then we can hit OK. All right, for the 8mm holes then, we're going to pick the face and also go with the S key. Pick our hole wizard item. And this time, instead of the M24, we're going to go back to M8 by 1.25. That's not an up to next condition. This is going to be blind condition. 2020 added the to shoulder or to the tip, and so the assumption in most cases is that this is going to be to the shoulder. All right, so 17mm. Oh, that was the diameter. Oops. Nope, M8 by 1.25. Double check here. Blind hole depth. Okay, 17mm, and the thread is to 2 times the diameter. On the callout, that one called it out 17mm deep, so that's going to be a little close for a standard tap to make it to that depth. So we have plenty of material, so we're going to go ahead and up to say 20, and we'll make the thread depth to 17. All right, so as long as we can get there. All right, and then I'm going to place the first hole location, and the selection, this is going to be a 10 holes by 16. Oh no, diameter of 10. All right, let me pull this up so I can read it. Diameter of 10. And I don't think there's 16 holes. 8 holes, 16. All right, well, you can also say through the gasket. Yeah, we'll go with that. And then our pattern, we need to pick up. One of these should have a bolt circle. And okay, so diameter 75 on the bolt circle. So for that, I don't think that we have to make this a center circle, but I always like to point out that there is just an object, but if I want this to act as a center line, then I have to go to for construction, or I kind of hovered over there for a second. We can toggle it to act as a center. So if there's some place where we want the circle for reference, but we don't want it to participate, we can toggle it out to a construction circle. All right, this is going to be horizontal, and then when I place the dimension, and grab the wrong one, so we'll go back and grab the center line, center circle, 75. All right, so, and that gives me my first instance. We're going to go with a circular sketch pattern, and the thing to watch out with this circular sketch pattern is it's going to put one at the center. That always becomes a little bit of an issue somewhere, especially when we take this over into the drawing and it sees 9 holes instead of the 8 that we've defined. So I'm just going to window pick and make sure that it's not there. Okay, at least I don't think it's there. We'll find out when we get to the drawing. This is an underdefined sketch, so I'll drag away, still underdefined. By the time I do it a second time and it goes coincident, they should all go to fully defined. So go back to the top view and hit OK. All right, so that's my first part, my first solid body. All right, and if I wanted to, I could put those in folders. If this gets more complicated, I probably would put it in a folder and manage them that way. So in the sketch, we're going to just highlight the sketch so I can see that profile again. go back into the revolve base. If we get back into the front view, then I can pick. And at this point, if I uncheck the merge result, then that is going to create a second body. Okay, so there's the revolve. And I would like to reuse the sketch. So that's the profile in the hole wizard. That is the point locations. So if I was to, let's go ahead and utilize the hole wizard again. So I'm going to pre-select. Well, on this one I would recommend pre-selecting, but if I don't, I hit the S key and go into the hole wizard. We're going to pick a simple, not a dowel pen, just standard drill sizes, and this one was going to be our M10. Get to it here in a second, and it's going to be up to next. And we also want to pay attention to the selected bodies. If it auto selects, it may go all the way through the part. If we force the selection, then it's just going to be the item that we pick. All right, and the position, since I did not pre-select the face, then it sees the 3D sketch. We don't want to pick the 3D sketch. We want to come right over into the work area and pick on that face. The 3D sketch goes away, and then I have access. Not that I can pick them, apparently, but we're just going to place those on top of the existing pattern. So if that pattern were to change, I would end up with an error, but for the most part, I'm going to be able to trace that error fairly easily and regenerate those geometries. All right, so I said I wanted to do the next M24 with the cosmetic thread and the annotation. We'll see how it's a little bit different, and we're going to uncheck the merge result again, and that was just out of habit. I showed the sketch. I picked in that region. Oh, and since that is included, or that section where before I picked that section, this time I didn't, that's going to leave the hole in the revolve. Okay, so that gets me to that point. And we'll go ahead into the annotation. If I pick on that edge then, and we're going to need to find it. So I've added it to my command manager, but we'll need to go over to Insert, Annotations, and Cosmetic Thread. Once we're in that cosmetic thread, then we're pretty much on the start plane. That's okay. If I go to Ansi Metric, there we go. Machine threads, it found the M24 by 3, but if we wanted to change it, we could go into the list, and the end condition will be up to next. Alright, so when I accept it, it makes a simplified thread form. Very similar to what the hole wizard did, but if for some reason this was an oddball, maybe we had a custom thread, or as a camera mount, or something with a strange number of threads, we could still be able to produce a callout for it and go through those calculations. All right, so on the face, click the S key one more time, and I could draw the 10mm circles and copy and paste them, or go through the process a couple of different ways. So again, I want to watch for the selected bodies and turn off the auto select. I might want to control these separately. So in my body selection, I could have left the gasket without, and then at this point told it to go through both of those items, but there may be a point where I find the gasket for an 8mm, I might want to go to 8.5mm or something on that. And I want those separate to be able to change it later on. So we'll go through and pick, and it's not that big of a deal to pick or set up another pattern. We could also set this up as a sketch-driven pattern. In fact, that would be, yeah, that would still work. So I'm hitting Control Z to get back out of those. And since I brought up the sketch-driven pattern, it is a good time to utilize it. Right, so my 10mm hole is highlighted. And if I go into the sketch-driven pattern, then the selections will be, I'll have to go back and find the first. So sketch 4 is the driving. It's going to be centroid on the sketch, and since the last hole wizard only went through that body, then the pattern should only go through that body as well. All right, so another option in creating those shapes. So if I read through this, then these three objects are the base, these two objects are the gasket, and the last three objects are the cap. All right, we'll go ahead and save this since I did not. And this is going to be new folder, P6-7, and I'm just going to abbreviate it multi-body. And this was the pressure cylinder. And since I want to have a separate, I do like to call these out, denote it somehow that is the multi-body or the master model. So if we hit save, that becomes our geometry. Now we have to do something with these bodies. So if this is the pressure cylinder cover plate, and then I can go to the pressure cylinder gasket. And then the pressure cylinder chamber. And then at this point, I can save the bodies. And this is where it gets interesting, as we're going to auto-assign the names. We're going to allow it to create an assembly. And I'm going to browse to the assembly. And this one can just be the pressure cylinder. And that way I can have the designation. I do not want to consume the bodies. I'm not really worried about the visual properties at this point. Derive resulting, I don't remember that one, have to look it up. And then part templates and assembly templates is going back a little ways, but that should be okay. When I hit OK, different units, yes, change the units. It's going to ask me that for each of them. And what it's doing is it's saving these out to the assembly and each of the three parts. So if this was fairly complicated, it'd take a little bit longer to have more geometry. So the rule is, I do not want to suppress inside of the saved bodies. If we need to make an adjustment or add geometry, then I can roll back. But suppressing has the unfortunate tendency to rename and may break the link to the other parts. So what are we getting with the other parts? The chamber with an external reference and each of the parts. It did not open the part, so let's take a quick look in the open. We have the chamber, the plate, and the gasket. So it did produce them, and it just didn't open them. All right, so now since this is a cylinder or an actual assembly, we can go ahead and add our fasteners. So either from the SolidWorks add-ins, we want to activate the toolbox, or from the pull-down, go into the add-ins. It'll take you to the same place. And toolbox library. I think if we do the SOLIDWORKS toolbox, it activates both the utilities and the library, so not any kind of big deal, but may just want the one. Alright, so the toolbox fasteners are going to live in the design library. So over on our task pane on the right side, we're coming to the design library, and then we'll see the toolbox. If we're not in an assembly, it will ask you if you want to create a drive part if you drag and drop fasteners into a part or into the mix. So make sure that you're in an assembly, and I am looking for no, it was just a standard hex. And double check I have that habit. Alright, so M8 by 1.25 by 30 long. And we'll go to machine. Nope. There we go, hex head. And I just want a standard hex bolt or a finish bolt, but when I grab that and drag it in, I'm holding down the left mouse button, and I don't want to let go till I get it in position. Alright, and it's going to find, nice, a 3/8 24. That wasn't exactly what I was looking for. So the assembly then, unfortunately, or fortunately as it is, we'll go ahead and just close that out. It is still in inch, pounds, and seconds. When I switch it over to millimeters, then I should be able to pick up a metric bolt. Or not. Okay, so I gotta remember where to change that out because we're not getting those. Okay, and since it was right in front of me, let's close that out one more time. In the design library, I went right into Ansi Inch out of habit. We're going to go over to Ansi Metric, which would help, and then we'll pick the hex head. And we have the different classes for the bolts, so if we go back to some of our charts, we can decipher some of those. And if I drag to that point, M8, length of, I didn't like something in there, it started at 40. Alright, so I'm going to close that out one more time and keep looking for one that I want. And it doesn't really matter where I start. Alright, so length of 12, that ought to get us a little closer to a length of 30. And we go ahead and hit OK. And I'm not sure why it showed the 100 there, but anyway, we're in the mode of adding these. So as long as I'm picking up those edges and it's finding those, it's automatically applying the mates and putting them in position. So these are capable of rotating, which is why they'll be underdefined. And one of the things I like to do, since we have those, is to create a new folder that is hardware. If we had lock ring or lock washers or star washers or something under this, or we go to the fittings for the M24 by 3, then I can do something with those. All right, so to create our exploded view, pull that out a little bit, and we're back in the assembly and the exploded view. Let's go ahead and pick all of the screws, just left click on the easiest to select part. My auto space components is turned off, so I'm going to do these as a group individually. Okay, so that one looks good. Now that one I didn't hit done, so if I want to take it out of the mix, I highlight it in the list, hit delete, and then hit done, and that should take it back. And then we'll expand that one out and hit done, and expand that one out. And notice that I have the little arrow on the right mouse button. I just got to get in the habit again of clicking on that. Alright, so there's our assembly in the multi-body. We'll create a drawing, but we'll do them at the We'll create the drawing next.